What is chemical engineering? Everyone knows that chemistry is the branch of natural science dealing with composition of substances and their properties and reactions, while engineering is the practical application of science in industry. But what about chemical engineering as a whole?
Basically, it is the use of knowledge about the properties and reactions of substances, plus other scientific knowledge to solve practical real-world problems. So, chemical engineers will apply these concepts to design, construct, operate plants and machinery for making products that we use in our daily lives. For example, dyes, drugs, plastics, and synthetic rubber.
So where are these plant and machinery located?
It is located in a place where you find raw materials being processed into products such as petrochemicals, fragrances, and soaps, using unit operations and processes, which is the chemical industry. In Singapore, chemical industries are mainly found in Jurong Island. The industry is the pillar of Singapore's economic success, in which many leading companies such as Shell, ExxonMobil, and many other companies are located there. It is a place where you discover many opportunities and career paths.
Oh, Shell! The petrol station which is always located nearby any block.
Yes, its industry is located in Jurong Island. So, if you're interested in making petrols, you know where to go. These are the possible job roles you can do in the chemical industry.
Nevertheless, to create chemicals and products, it must undergo chemical processing.
Chemical processing?
Chemical processing is the process of changing chemical compounds via chemical reactions, and this involves substances of high chemical reactivity, high toxicity, and high corrosivity operating at high temperatures and pressures.
Well, if it's not handled carefully, it will lead to explosions.
Ha.
Anyways, these are the important factors to take note of when doing chemical processing. 1. The size of reactor. 2. The plant operating cost. 3. The rate of reaction. And 4. The quality of the final product. You must also take note of the safety requirement, pressure, temperature, concentration, catalyst, reaction time, site reaction, reactants, and the reactor sequence during the process.
It seems like a lot of work.
Well, being precise is very important while working in the industry, as you wouldn't want to make products of low quality and safety is the top priority.
Yes, moving on. Chemical process requires a lot of unit operations to obtain the desired product from the raw materials. Therefore, every single unit operations are important in the chemical plant in producing individual coherent reactions. Each unit operations involve physical changes. For example, physical separation of substances using distillation. No chemical reactions are involved. In unit operation, the law of conservation of mass and energy states that mass and energy can neither be created nor destroyed. Thus, in a processing plant, the total mass of materials entering the plant must be equal to the total mass of material leaving the plant, provided there is no accumulation in the plant. Mass in equals mass out. The same concept applies for energy. The total energy in the materials entering the processing plant plus the energy added in the plant must equal the total energy leaving the plant. Unit operations are classified into many components. There is the gas absorption, cooling tower, fractional distillation, and liquid-liquid extraction.
Let's zoom in on the liquid-liquid extraction. Liquid-liquid extraction is an important separation technique in modern process industry. It separates mixture of liquids, preferably soluble, by treating it with an immiscible solvent. Take for example, a mixture of organic solvent plus propionic acid and water as the immiscible solvent.
Wait, what is an immiscible solvent?
By immiscible solvent, it means that the solvent will not form a homogeneous mixture when mixed. Basically, it just means that the water will not get mixed with the mixture. So, this is a schematic outline of liquid-liquid extraction. The process is countercurrent flow in rotating disc contactor where liquid-liquid extraction takes place. The process involves a mixer. So what happens is, the mixture will enter as the feed into the rotating disc contactor above, while the solvent will enter from below. The mixer will start to turn and bring the mixture and immiscible solvent together, creating intimate contact between them. This is important as rate of separation is dependent on area of interface between the immiscible liquids. The process is continuous and liquid will flow countercurrently until equilibrium is reached. Like what we've learned just now, mass in must be equals to mass out. However, this is an assumption as we cannot determine if equilibrium will really be reached between the phases in reality. Nevertheless, the reason why propionic acid can dissolve in the water even though water is immiscible in the mixture is because propionic acid is soluble in water while the organic solvent used is insoluble in water. The process also requires packed or plate columns and serves as the same function like the mixer, which helps efficiently contact the phases together. Moving on, while mixing, propionic acid, which is soluble in water, will dissolve in the water and exit as the output known as the extract phase. We can also say that the propionic acid is extracted by the water, hence the term liquid-liquid extraction. So, the extract phase will be propionic acid plus water. But where will the organic solvent go to? The organic solvent will exit as another output known as the raffinate phase. In the raffinate phase, it contains the organic solvent plus trace of propionic acid. As propionic acid might not dissolve completely in water at one go, it may require multiple stages with liquid flowing countercurrently in order to achieve high purities and yields as well as a state of equilibrium. Therefore, raffinate phase will exit and enter as feed again in another stage. This process will continue until high purities and yields are achieved. Also, we must not forget that the choice of solvent is critical in affecting a liquid-liquid extraction. In this process, the immiscible solvent is water because it is immiscible in the mixture of organic solvent and propionic acid. But we must not forget that there are other types of mixtures, and water might not be a good immiscible solvent to treat and separate the mixture. Hence, we must consider the following factors when choosing a solvent to use: density, viscosity, interfacial tension, volatility, high selectivity, partition coefficient, stability, corrosivity, toxicity, and cost.
Whoa! But normally, we just use solvents that is used in similar processes as no solvents will meet all the criteria though.
Yeah, so now you know what is liquid-liquid extraction. This process is used a lot in the industry as a source of separating food products of flavors. So it is important to take note of the criteria and measures necessary to carry out the process more efficiently.
I see. Wait, separation of liquid? Why not use distillation instead of liquid-liquid extraction?
Good question. Liquid-liquid extraction is mostly used when separations of components by distillation is either uneconomical or even impossible. Distillation is used to separate various components with widely differing boiling points. Basically, it is the process of extraction involving the boiling of mixtures. However, some mixtures have thermally sensitive components in which they are sensitive to high temperatures. And by using distillation to boil them, it will denature the components. In other words, the quality of the component will be altered. Hence, this is where liquid-liquid extraction comes into place. Liquid-liquid extraction does not require boiling of mixture, hence it is used for separation of temperature-sensitive components.
Alright, thanks. Now I have gained a new knowledge about the liquid-liquid extraction.
You will see that in the industry, we deal with a lot of plants, machines, and unit operations. Each of these are important in producing the products more efficiently and creating the things we always use in our daily lives. From the chemical industry and zooming into the process and unit operations, we use our knowledge in constructing a more efficient operation, undergo chemical processing, and finally, using the operations to get our final product.
Well, this is what chemical engineering is all about.